Today we are going to start a new chapter which is semiconductors. Later before we have learned what is insulators and conductors. Now conductors has got a property called as conductivity, which means they will allow charges to move from one end to another end whenever electric field is applied across it. So they have free electron. So because free electrons are the charge carriers in the case of conductors. Now these free electrons, let me represent it for you. We have a metallic conductor, say copper. Now these are having free electron. These dots represent free electron. When I am connecting a potential difference or an electric field. So potential difference is nothing but an electric field at a point, right? Now when we are connecting a potential difference, these electrons will be attracted towards the positive terminal. So these are the electrons which doesn't belong to any atom. Okay, free electrons means these electrons are free to move. Say for example, we have an atom to having electronic configuration 2, 8, 1. Now 1 is in the outermost orbit, or we can say it as valence electron. Now these electrons are less bound to the nucleus because they are one electron, and this atom will get stability when they release this electron. Okay, which means when they release this electron, what will happen? Now this particular atom will have stability because it contains 8 electrons in the valence orbit. So there are multiple reasons for an element to behave as conductor. One reason is on removing one electron it will get stability, and the next reason is these electrons are less bound to nucleus. So whenever they are getting higher energy in the form of heat or light, energy in the light, this electron will come out of the orbit. Now before this electrons was bounded electron, this was bound to nucleus. Okay, this belongs to a particular atom. Now once the electron become free, these are free electron. These electrons will be in the lattice, or I can say would be in the void. What is void? We have one atom, another atom, another atom, another atom. Now this free electron will come to the void in the atomic arrangement. This electron would be in the random motion when we are not giving any potential difference. Okay, so I can draw 4 different electron here. So one would be moving in this direction, one would be moving in this direction, one would be moving in this direction. So here it is random movement, so that there is no net electric current moving across the conductor. But when we are providing a potential difference, now all the electron would be coming towards the positive terminal of the battery because they are now drifted. There is a force that this electric field is applying on the free charge carriers, the free electrons. Okay. Anyway, conductors has got a property of electric conductivity. So they have very high conductivity, and I could say that very low resistivity. What is resistivity? That is the opposition for the movement of charge carriers. So conductors offers lesser resistivity, more conductivity. May I know what is the reason for higher conductivity? The reason is it has higher number of charge carriers. These charge carriers, whenever potential difference is applied, they will come along the direction of, electrons will come opposite to the direction of electric field. Anyway, electrons would be drifted in electric field, making a current. Okay, so conductors has got this property of higher conductivity and lower resistivity. Now in the case of insulator, the resistivity is very high. Okay, which means whenever we are providing across a insulator, when I am providing a potential difference, this doesn't allow charges to move. What is the reason? It doesn't have any charge carriers inside. Now in the case of conductor, I told you there will be one free electron. These free electrons, when applied with potential difference or electric field, they would be drifted, right? In this case, there are atoms, there are electrons, but these electrons are just revolving in the orbits. Now only the electrons, whenever they are free, they can contribute towards the conduction. Okay, so now here I can say in insulators, electrons are with atom or in the orbits. These are not free to move. In the case of insulator, that's the reason it has got higher resistivity, has very less number, or I can say no free electron. Now with semiconductor, okay, so here resistivity would be more and 1 by resistivity is conductivity. We know that resistivity is equal to 1 by conductivity. Okay, so here conductors property is higher conductivity and resistors property or insulators property is nothing but higher resistivity. So higher resistivity can also be told as lower conductivity, and in the case of higher conductivity can be called as lower resistivity. In the case of semiconductors, its conductivity and resistivity are in between conductors and insulators. So here resistivity is in between conductors and insulator, and conductivity is in between conductors and insulators. Okay. Now with respect to atomic structures of conductor, semiconductor and insulator, I will explain you why it is showing different conductivity. Within the case of conductors, its valence electron, its valency would be 1, 2, 3. What is valency? The number of electrons in the outermost orbit. If it is having 1 electron, I could say that this is conductor. 2 electron conductor, 3 electron. Till 3 electron it is conductor, because these atoms can immediately release these 3 electrons whenever they are getting energy. See, atmospheric temperature itself is an excited state. Why? You know, we are at atmospheric temperature is 27 degrees Celsius, which is 300 Kelvin. Now 0 Kelvin represent a scenario where the temperature is 0 or energy is lowest. Now we are at 300 Kelvin. So at this temperature there are a lot of free electrons with conductors. Now conductors are having valency up to 3. Up to 3 means 1, 2, 3. So whenever it is having 1 electron, that will have higher conductivity, because this can immediately release 1 electron. Okay. Whenever it is 1 electron, that will be very loosely bound. 2 electron, you know, force would be more offered by nucleus, but still it can release 2 electron, and 3 electron also it can release 3 electron. But anyway, this released electron or free electron, they can contribute towards conduction. Now in the case of insulators, their valency would be 5, 6, 7 and yeah 8 also. So this if they are having higher valency, that represent higher amount of attractive force offered by nucleus. For example, having higher valency, 5 number of valence electron. So if there are 5 number of valence electron, this has very less tendency to give away the electron to make it free electron. Okay, that will keep the valence electron within itself. Okay, so if it is keeping the valence electron within itself, what will happen? There are no charge carriers. Now when we are applying potential difference, there are no charge carriers to drift along the direction or opposite to the direction of electric field. Now see, along the direction of electric field, positive charges would be drifting, because if this is electric field, I am keeping a positive charge, that will be moving in this direction. Now if I am keeping negative charge electron, then that would be moving in this direction. I will make it more clear with you. Okay, this is positive charge plate, this is negative charge plate. Electric field is in this direction. Now if I am keeping a positive charge here, this positive charge will move in this direction, because positive will repel the positive charge and negative will attract the positive charge, and that will come in this direction. So this is drifting along the direction of electric field. Now if it is electron, what will happen? That will drift opposite to the direction of electric field. This is the direction of electric field here. Now this electron would be attracted by the positive plate and repelled by the negative plate. Now onwards I would say that charges are drifted along the direction of electric field, which means that in the case of conductor, these charges are electrons, and this electron will always drift opposite to the direction of electric field. So don't get confused. Generally positive charges we would be considering for the movement of or for the reason for current. So positive charges would be moving in the direction of electric field, but negative charges, electrons, would be moving opposite to the direction of electric field, and it is always in the case of conductors, free electrons or electrons making the motion. In the case of insulators, so in the case of semiconductor, we will learn that positive charges will also move. But here anyway it is electrons, that in the case of conductors it is electron that is making electric current. So this electron would be drifted opposite to the direction of electric field. Don't get confused whenever I repeat the same thing. That is electrons drifting opposite to the direction of electric field. Okay. Now, so that is the case of insulators. With semiconductors, their resistivity is in between and conductors is in between. What is the reason? They are having 4 valence electron. Here also 4 valence electron. Okay. Now, whenever they crystallizes, just a second. Yeah. Whenever they crystallizes, how would be the atomic structure? Silicon, it has 4 electron. Silicon, it has 4 electron. Now these 4 electron, when they accept 4 more electron, that has stability, right? Because that represents a valency of 8. So what this silicon do? That will take that would share 4 electrons from nearby atom. Okay, I would draw this here. See, now this silicon was only having, see, these are the 4 electrons that this silicon owns in valency. Now this silicon will share 1 more electron, it will share its electron and also it will share 1 more electron with the nearby silicon. So see, this silicon, yeah, this silicon offers its 1 electron, okay, and this silicon also will offer its 1 electron. This silicon will also offer 1 electron, and the upper silicon will also offer 1 electron. Now these 4 electrons are owned by the same silicon, and these 4 electrons are owned by nearby electron, but they are under sharing. So now this silicon can also share this electron and this electron. So now see, every silicon atom will get a valency of 8 electrons now on sharing. See, on sharing, this will have a valency of 8 electron. So that is a case of stability. See, 1, 2, 3, 4, 5, 6, 7, 8 for this silicon. Now for this silicon 1, 2, 3, 4, 5, 6, 7, 8. Now this silicon 1, 2, 3, 4, 5, 6, 7, 8. Now every silicon, so silicon, this would be the structure of silicon crystal. Silicon or germanium, if it is having a valency of 4, see, it will make double bond with the nearby, yeah. So these are covalent bond. Okay, this inner silicon has 1, 2, 3, 4, 5, 6, 7, 8. This is having 1, 2, 3, 4, 5, 6, 7, 8. So all the silicon has got the stability. And how is this possible? Every silicon atom will share its 4 electron, and that will also share 1 electron each from the nearby silicon atoms, so that it will have 8 electron in the valence orbit in a shared condition, thereby attaining stability. Okay, so silicon, its atomic electron configuration is 2, 8, 4. 4 valency with silicon, this is germanium, okay, sorry, germanium 284 with silicon 2884. So these represent valence 4 electron. Now on crystallization, these 4 electrons are highly stable condition because they got a valency of 8 now on sharing with 4 nearby silicon atoms. Now see, will this electron come out? See, if the electrons are coming out, that are basically going to an unstable condition, right? So at lower energy, taking out this electron is difficult. But when we are heating, now at 300 Kelvin, there would be some electron generated, but I would say that I am going to heat it to 100 degrees Celsius. 100 degrees Celsius means 400, yeah, 100 plus 273, so 127, say for example. So that is 400 Kelvin. Now at higher temperature, these electrons will get energy to move from its position, that is from the shared condition, and to become free. I would repeat it. Say for example, now we have 2 electrons here. At higher temperature, this will get energy so that this electron will move outside. It's a free electron now. Here it is bonded electron, right? Here in this case, at higher temperature, this electron came out from its position and that became free here. See, free electron. Previously, that was bonded electron. That cannot contribute in conduction because these are not free charge carriers. Now, at higher temperature, this electron will get energy and that will jump from its bonded condition, that is shared condition, and this will become a free electron here. Now, this free electron can move across the element. How it can move? Whenever we are applying potential difference across it. Now see, let's say we have a silicon crystal which is heated to 500 Kelvin. Now when it is heated to 500 Kelvin, there are many free electrons generated. Now these free electrons are available here. Whenever I am applying a potential difference, what will happen? This electron would drift opposite to the direction of electric field. I have told you here. So this is the electric field, that electron would be drifted in this direction. Here positive charges are also being drifted, but I will explain you in coming lectures. But anyway, this will contribute towards conduction. Okay. So we have learned few things here in this video. One thing is, semiconductors are generally insulators at lower temperature, because at lower temperature it doesn't have free electrons, but at higher temperature free electrons would be generated and that would be contributed, that would contribute towards conduction. Okay, so at higher temperature free electrons are generated, at lower temperature it has no free electrons to contribute towards conduction. So semiconductors, conductivity and resistivity, yeah, either conductivity or resistivity, that is purely dependent on temperature. Now the atmospheric temperature is 27 degrees Celsius. Now later in the evening that will come down to maybe 25 or 24. At that temperature its conductivity and resistivity would be a completely different value that it shows at this moment. Okay, now we have learned this thing, that this can behave as insulator and also as conductors, depends on the temperature where we are keeping it. Okay, and also there are multiple scenarios. These are pure, elements what I am talking about as insulators. We have different types of insulator: gallium arsenic, then indium phosphate, then cadmium cesium, cadmium sulfur. So these are inorganic semiconductors, but in this case, in the case of elements, I have told you this is the reason, this is how it is behaving as semiconductors, and its resistivity and conductivities are in between. And with respect to temperature, that would be highly resistive. When temperature do change, their resistivity and conductivity changes. Okay, thank you.